Experiment number 5. Determination of moisture content. This experiment aims to determine the moisture content of the given sample. The experiment determines the moisture content of soil by measuring the mass of water lost during the oven drying process relative to the mass of the remaining dry soil solids. Moisture content is considered one of the most important index properties in geotechnical engineering because it greatly influences the physical and engineering behavior of soils, including strength, compressibility, permeability, and consistency. By accurately determining the amount of water present in moisture content is highly sensitive to environmental conditions, which is why proper handling and storage of soil samples before testing is important. If a sample is exposed to sunlight, wind, or excessive heat before weighing, moisture may evaporate and lead to inaccurate results. In geotechnical engineering, even small changes in water content can significantly affect soil behavior. For example, soils with high moisture content generally exhibit lower shear strength and higher compressibility, while drier soils tend to be stronger and more stable. The moisture content test is also widely used in field and laboratory quality control, particularly in earthworks and compaction operations. Comparing the natural moisture content of soil with its optimum moisture content helps engineers determine whether the soil condition is suitable for compaction. In addition, different soil types retain water differently. The soil sample engineers can better evaluate the condition and stability of the ground for construction purposes. The results of this test are also essential in establishing soil phase relationships and in performing other laboratory analyses such as compaction, Atterberg limits, and density tests. Proper determination of moisture content helps ensure that the soil can safely and effectively support structural loads in various engineering projects, including buildings, roads, embankments, and foundations. These are the equipment that you will be needing: non-corrodable container, drying oven, weighing scale, and soil samples. Here are the steps for this experiment. First, prepare a clean and dry moisture container. Using a balance, weigh the empty container and record its mass as W1. Before measuring, make sure that the balance is properly tarred to ensure accurate readings. Next, place a representative soil sample into the container. Weigh the container together with the moist soil specimen and record the combined mass as W2. After weighing, place the container with the soil sample inside the oven. Allow the specimen to dry for approximately 16 to 24 hours, or until it reaches constant weight. Maintain the oven temperature between 105 degrees Celsius and 115 degrees Celsius throughout the drying process. For peat or organic soils, use a lower drying temperature of around 60 degrees Celsius and extend the drying period to avoid burning the organic matter. Once the drying process is complete, carefully remove the container from the oven and allow it to cool to room temperature. Then, weigh the container with the dried soil sample and record the final constant mass as W3. These measurements will then be used to determine the moisture content of the soil sample. Repeat the process for other trial. The moisture content of the soil sample was determined using the oven drying method. Based on the results, the computed moisture contents for the three samples were 3.01%, 4.28%, and 3.21%, respectively. These values are relatively close to each other, indicating consistency in the testing procedure and reliability of the results. The average moisture content is low, suggesting that the soil sample is relatively dry and contains minimal water. This condition may imply that the soil is more granular in nature or has low water retaining capacity. Overall, the experiment was successfully conducted, and the results are within a reasonable range for comparison and analysis. Thank you so much for watching. I hope you learned something today.